All right, so today we're going to talk about the last type of trig equations that we need to solve. And these are what are called multiple angle trig equations. They're basically equations that we're solving that have a situation where we double the angle. We could talk about half angles. So for now, we're going to focus on a situation where we're trying to double the angle, right? So the good news is we're still going to do this the same way we've done all of our other equations. Get the trig function by itself, then do our quadrant analysis. So we got to figure out where where sine is negative. Sine is negative in quadrant 3 and 4. All right, now I'm looking for an angle in quadrant 1 whose sine value is 1/2, and that's 30 degrees. And so our distance from the horizontal is 30 degrees everywhere. That's what we're going to use to find our angles. So those angles are 210 and 330 when you use your quadrant rules, okay? Now, that's not necessarily our solutions though, right? If we type in sine of 210 degrees, that will tell us, our calculator will tell us that that's negative 1/2, okay? So what that means is that 2 theta is supposed to be 210. So 2 theta is supposed to be 210, or 2 theta is supposed to be 330. So to actually find our missing value of theta, we've got to divide by 2. So we're going to divide both these guys by 2. And so we get 105 and 165. Okay? And so again, these are solutions. 105 and 165 are what we should plug in for theta. And that makes sense. If we put in 105 to theta, 2 times 105 is 210. Sine of 210 is negative 1/2. So that works, right? Same thing would happen if you plugged in 165. 2 times 165 is 330. Sine of 330 is negative 1/2. Okay? Now, let's just say I wanted to see if 285 was a solution, right? So you plug in 285 for theta. 2 times 285 is 570. If you were to type in sine of 570, your calculator will tell you that's negative 1/2. So apparently 285 degrees is a solution for theta as well. But we didn't find it the first time through. So why not? It's like a hidden solution. What happened? Well, the reason why we stopped, the reason why we didn't see it is because, again, when you take 2 times 285, you get 570. And so 570 is not within what our normal parameters are, right? If you look at the top of your notes, you see that theta, or x, has to be between 0 and 360. So anytime we start getting outside of that, we stop looking for solutions. But if we look down here, 285 is the angle that I came up with. 285 for theta is definitely in that interval, 0 to 360. So it's a solution. It's a solution that we're allowed to use. So again, why didn't we find it? Because when we start talking about 2 times 285, we get 570. And 570 is not within that unit circle unless you wrap around it. So how are we supposed to find that? Well, we need to understand that if x has to be between 0 and 360, then 2x has to be, if I multiply 2 times 0, I get 0. If I multiply 360 times 2, I get 720. So 2x, or 2 theta, is allowed to be between 0 and 720. So that means we've got to wrap around the circle until we get to 720. 720 kind of becomes a cap for us. But that's for 2x, right? So in other words, when I found 210 and 330 as potential solutions, I needed to keep wrapping around so that I can get other angles in the interval of 0 to 720 to give me possible solutions as well. Now, I keep saying wrap around because if you're here at 210 and we go all the way around the circle and come back, we're going to land with the terminal side in the exact same spot, and our sine value will still be negative 1/2. And when you go all the way around the circle, you're actually adding 360. So what I want to be able to do, or what I need to do, is take 210 and add 360 to it and get 570 degrees. Which again, for 2 theta is fine. We just don't want to be more than 720. Same thing for 330. Right? So you got 570 and 690 that 2 theta could be. If I add 360 to 570, I get 930. 930 is definitely over our cap. We can't use it, so we stop adding 360. But these are all 4 values that I need to divide by 2 so that I can get the solutions. So we've already done it for 210, 330, and 570. We need to go ahead and divide 690 by 2. And so theta is 105, 165, 285, and 345. Those are our solutions. Okay? So a lot of explaining as far as what we're doing, right? But bottom line is, when we get our angles for 2 theta, we need to keep wrapping around the circle until we get to our cap, keep adding 360 until we get to our cap for all of our possible solutions. And then we're going to try to find theta by just dividing by 2 here, or dividing by whatever the coefficient on theta is. Okay? So it's a little bit about why we do what we do. As we work more problems, I think it'll be less confusing. So let's try this next guy. Okay? Get our trig function by itself, which it already is. Now do our our quadrant analysis. Cosine is positive in 1 and 4. In quadrant 1, cosine is radical 2 over 2 at 45 degrees, so that becomes our distance from the horizontal. So that means that what I'm going to put in for 2x, excuse me, what 2x is allowed to be is 45, and subtract 45 from 360, you get 315. But again, if you go back up into the allowed values of 2x, 2x can go as high as 720. And if I add 360, I get 405. 405 is allowed for 2x. If I add 360 to 315, we get 675. That's allowed as well. If we add 360 to 405 again, we're going to be over our cap of 720, so we can't use those. And then to find x, I just divide all these guys by 2. So x is going to be 22.5, 157.5, 202.5, and 337.5. Okay, so those are all your solutions.
Students and staff, please find this interruption.
All right. Hopefully that makes a little bit of sense. Let's try one more. And let's take a look at tangent. So tangent of 3x is by itself. We're ready to do a quadrant analysis. Tangent's positive in quadrant 1 and quadrant 3. And we have to go to 30 degrees in quadrant 1 in order to get a tangent value of radical 3 over 3. So my distance from the horizontal is 30. That means 3x can be 30 degrees or 210 when you add that to 180. Okay? Now, notice that it's 3x and not 2x. That means that 3x has a little bit different cap. Again, x has to be between 0 and 360. 3x has to be between 0 and 1080 if you multiply everybody by 3. So now I need to start adding the period, and that's what we didn't explain with sine and cosine. The reason why we're adding 360, and the reason why we wrap around the circle 1 revolution is because that's the period on sine and cosine. It takes all of the entire circle to have those values repeat. But in tangent, if you think about the graph for tangent, the period on tangent is pi. That's how soon pi repeats its values. Pi is 180. So what does that mean? That means that every 180 degrees, tangent's going to repeat its values. So instead of adding 360, we have to add 180. And that only is because we're dealing with pi. No, I'm sorry, we're dealing with tangent. So 3x could be 30, 210, or if we add 180 to 30, we get 210. If we add 180 to 210, we get 390. Add 180 to 210, we get 390. We're adding 180 every time. Then this next guy becomes 560. So 560 here. Add 180 to 560, and we get 740. Add 180 to 360, you get 740. Add 180 to 740, you get 920. Add, let's see, so 920 here. And again, we're going to keep going until we hit our cap. Our cap is 1080. So add 180 to 920, and we get 1110. That's too much, so we got to stop. Okay? Okay, now, is there any reason to list angles twice? Right? If we're going to have solutions, there's no reason to list angles twice, right? So the fact that we got 210 twice, 390 twice, 560 twice, 740 twice, and 920 twice when we added all of our 180s means that we can just kind of ignore the copies, ignore the second ones, right? And then to find x, we're just going to divide everybody by 3. So x could be 10 degrees. 210 divided by 3 is 70. 130. 130, and then we go 1. Wait, did I mess this up? Oh, this should be 570, I think. So I'd added my 180s wrong. If that's what you were thinking, then you were right. So 5, 6, 750 here, which means this would have been 750, and then 930 here would have made this 930. So I was off by 10. All right. So anyway, so 130, and then 190, and then 250, and 310. Okay? And so those are our solutions for x. Okay? So we were capped at 1080 because we were multiplying our angle by 3. And we were adding 180 instead of 360 because we're dealing with a tangent function instead of a sine or a cosine. All right? All right. I think it makes enough sense. If it does, try 4. Stop the video. You can start it back up. And then see how you did. All right. Did you get these? 0, 60, 120, 180, 240, 300, and 360. Okay? Again, sine is 0 at 0 degrees, 180, and 360. And then, because we're dealing with multiplying the angle by 3, our cap becomes 1080. So we're going to add 360 because it's sine. We're going to add 360 to all 3 of our angles right here up until we get to 1080. You can see the angles listed there. We delete out the ones that are copies and then divide them by 3. That's it. Okay? If that doesn't make any sense, make sure you come find me. We'll walk through it together. Okay, but to continue, the other equations that we solve with these guys are going to be the same process that we've done in our other equations. Like I said, we got to have cosine by itself. And in number 5, we don't have that. So we divide by 1. I'm sorry, subtract 1. And then divide by 2 to get cosine of 2 theta equal to negative 1/2. And everything else stays the same. So we do our quadrant analysis. Cosine is negative, which is going to happen in quadrant 2 and 3. In quadrant 1, cosine is 1/2 at 60 degrees. So that means the distance from the horizontal is all 60 degrees. That means that the possible values that 2 theta could take are 180 minus 60, or 120. 180 plus 60, which is 240. Okay, but we know that our cap, if we multiply our interval by 2, is 720. So we're going to add 360 and get 480 here, add 360 and get 600 here. If we add 360 to 480, we'll be over 720, so we're capped out. Now everybody gets divided by 2, and so theta turns into 60, 120, 240, 300, and we're done. All right? All right, next one. Same thing, it's sine. So to get sine by itself, we got to subtract the square root of 3, which is perfectly fine. Divide by 2. Okay, do our quadrant analysis. Sine is negative in quadrant 3 and quadrant 4. Now in quadrant 1, sine is radical 3 over 2 at 60 degrees. So that becomes our distance from the horizontal. And so now 3x could be 240 or 300 out of quadrant 3 and quadrant 4. Okay? Now our cap is 1080. Right? Again, it's because we're multiplying the angle by 3. So we want to keep adding 360. Add 360 because it's sine until we get to 1080. So if you add 360 to 540, you get 600. And then 660. And then 660. And then 9, let's see, 10, 20. And then 10, 20 here, and then we're capped out, and so we stop there. So now if you look, we've got a 660 here and a 660 here. Oh, so, right, we've got two 660s, so don't worry about one of them. We got two 1020s, don't worry about those guys. And so we divide everybody by 3. Hold on, back up. Duh, sorry. Been a long day. Let's back up for a second. So if we add 360 to 240, we get 600. 600 plus 360 is 960. Right? And then if we add 360 to 960, then we're over our cap. So missed an angle there. Sorry. So we don't have any duplicates. So we're going to want to multiply all of those by 3. Right, so we get 80, 100, 200, 220, 320, and 340. And those are our solutions. Okay? All right. Next one. Okay, let's take a look at 7. 7's a little bit different. Well, for a couple of reasons. One, it's tangent. And 2, when we get tangent by itself, we got to divide by 3. And so we get tangent of 2x equal to 1/3. So we do our quadrant analysis. Tangent is positive where? Well, it's positive in quadrant 1 and quadrant 3. And where in quadrant 1 is the value of tangent 1/3? Well, nowhere, right? So we have to go to our calculator. We have to do inverse tangent. So inverse tangent of 1 divided by 3 means that our angle is 18.43 degrees, which means that our distance from the horizontal is 18.43 degrees. So that means that 2x can be 18.43 or it can be 180 plus 18.43, or 198.43. Okay? Now, again, we're multiplying our angle by 2. So that means our cap is 720. So we want to add, now this is tangent. So again, tangent repeats its values after 180 degrees or pi. So we have to add 180. Remember that we're adding 180 when we work with tangent. Right? So add 180 to 18.43 and you get 198.43. Add 180 to 198 and we get 378.43. That's what we're going to get here again. We're going to keep adding until we get to 720. And if we add 180 to 558, that'll put us over our cap, so we've got to stop. Now, there are two 558s, there are two 378s, and there are two 198s. So we can ignore the copies. And now we got to take all of these guys and divide by 2. So, x is 9.2 degrees. Uh, 99.2 degrees. 189.2 degrees. 279.2 degrees. And 369.2 degrees. Okay, and we're done. Okay, so remember tangent, you're adding 180. All right, so try 8. Stop the video, see what you get, and then I'll show you what you should have gotten. And if you have questions after that, you can come in and see me. We'll go through it. And that's what you should have gotten for number 8, right? 50, 70, 170, 190, 290, and 310. Make sure you're adding 360. Okay. A little bit different here from what we were talking about, right? Remember that cosine is negative in quadrant 3 and 4. I'm looking for that angle in quadrant 1, whose cosine value is radical 3 over 2, and that's 30 degrees. That's what we mean by reference angle right here. And then use that as your distance from your horizontal to find your other angles, okay? Now, in thinking about this, I did, number 7, include 369.2, but obviously for x, 369 is outside of our interval that we want, so that's not going to be an acceptable angle. So we'll just get rid of it. Don't include it because it was too big. Okay, if that's what you were thinking when we were going through the problem, then you're right. So, but there you go. All right, if that doesn't make enough sense, again, come find me and we will definitely walk through it together. Otherwise, homework's in Canvas. Bring your questions next time.